So here in this question, we have to calculate tension, and tension, as I said earlier, the tension is a variable force. It really depends upon the other known forces, and we can simply calculate it looking at the other forces first, right? The question says calculate the tension in the string joining the two masses. So the two masses 10 kgs and 30 kg, and we have to find what is the tension in the string. Okay. So as we can see, if I'm going to pull this with a 60 Newton, both of them will move together, right? So we can simply assume that both of them are a part of a system and they're going to move with the same acceleration, right? So if we assume that, basically the total mass will be 30 plus 10, which is going to be 40 kgs, okay? And the now force which is acting is only this one, right? This is the only external force. This is now an internal force. So we don't worry about internal force. With that, we can find its acceleration. What will the net acceleration? F is equal to m, which is 40 into a, and F is given to be 60 Newton, right? So my acceleration is going to be 60 by 40, which is 1.5 meter per second square towards right, okay? Towards right, okay? So once we found the acceleration, we can straight away find this tension, because this mass is also moving towards right with the same acceleration, right? Both of them are moving with the same acceleration. The acceleration is 1.5 meter per second square. And this is the tension which is pulling this block towards right. So we can write F equal to ma for this, right? So F, which is equal to tension, is equal to mass 10 into the acceleration 1.5. And that is going to be 15 newtons, okay? So my tension is 15 newtons, okay, in part A. Now it is saying if the position of the masses is interchanged, what will be the tension? Okay, so we can again do the same thing, right? So if it is now, this one is here, the 31 is here, and the 10 one is here, and basically we are pulling it. So we are going to get the net acceleration for the system, which will be exactly same, right? Because both of them are moving together to be 1.5. Now, this means the 30 block is also moving like that, and this time with the same acceleration 1.5 meter per second square. So now the tension in the part B, which is going to be F, is going to tension in the part B, is going to be mass, which is 30, right, into acceleration 1.5, and this time it is going to be 45 Newton, right? So the tension will change, right? Think of this. Now what's happening here is that we are applying a 60 Newton force, and it is first pulling this 30 kg mass, right, providing that 1.5 acceleration. So part of that force is sort of consumed, and whatever is left is also pulling this one, right? If you do other way around, because this is a smaller mass with the same acceleration, less force is getting consumed, right? So hence the tension in the string is higher and bigger, right? So in case number 1, 15 Newton, in case number 2, 45 Newton.